Hello, Rick Off here. Welcome to video number 29 of Rick's Pipe Dream Magnetic Motor Generator Project Series. In this video, I'll be picking up right where I left off in video number 28. We'll be showing another pull test using the digital pull scale. Now I have moved the rotor slightly so that the last magnet of the rotor group is just past the stator, and this would be in an excellent position for repulsion. We would have the strongest repulsion effect at this point if the stator magnet can be moved quickly right at this position. Now let's see the force that's required at this point to begin moving the stator. If we watch the stator very carefully to see when it begins to move and note our reading at that point. There, it started to move. That was between 4 and 5 ounces where the movement started to occur. So that's just half the amount that was required previously when the stator magnet was still engaged with the rotor magnet group. So, as you can see, as the rotor group moves farther away past the point of engagement with the stator magnet, the force required to move the stator magnet rapidly diminishes. Now this position of rotation is the most crucial position in the entire rotation. And the reason for this is because since the last magnet of the rotor magnet group has passed by the stator will now begin to be in reattraction mode, attempting to pull the rotor backwards. To avoid this, the stator must be moved at this point. Ideally, of course, the stator would already be shifted, pole shifted at this point, giving us maximum repulsion effect instead of reattraction. It may not be possible to actually switch the poles at this time, at this point in the rotation, but the movement should be at least be underway, and if we can at least get to the midpoint of the movement, this will prevent any reattraction of the rotor. Let me just show you a demonstration of the midpoint as a null factor. Now this isn't precisely a top-down view, it's a little bit of an angle, but it's fairly close. So you can see that the center of the stator magnet is positioned over the center of the rotor magnets. And I'm going to give this just a little bit of a hand spin, just a very light amount, just to show you that the rotor magnet group will continue past the stator now without any reattraction. Okay. So this demonstrates that if the stator can be moved to this midpoint at the tail end of the rotor magnet group, then rotation will continue. The question now becomes, what if we are only able to move the stator to the midpoint of its movement? What happens? What happens when the next approaching rotor magnet group comes along? Will we have any attraction effect at that point, or is it still going to be in a null position, which will not really give us any acceleration? Well, to answer that question, let's move the rotor. I'm going to move it by hand now. Give it a slight spin just to start it moving, and we'll see what does happen with the stator magnet. Okay, it shifted, didn't it? Let's back up and let's see that again. Put the stator magnet in a midpoint orientation and give the rotor a little bit of a spin. Okay, yes, it shifted into the full attraction position and accelerated the rotor. Now, of course, when we get to the end of that rotor group, we're going to have a reattraction problem, unless, of course, the stator can be shifted at that point. We need 4 shifts during every rotation. The shifts always need to occur at the tail end of a rotor magnet group. But let's just say that we have a rotation going. We've shown that the stator is capable of self-alignment if it's moved at least halfway. What happens if it wasn't moved at all? Would we still get a shift of pole? Let's see what happens in that case. I'm going to give this a hefty spin, and let's watch what happens. Well, yes, the pivoting stator does move into full attraction position as it engages each magnet group. Of course, it's slowing down and it stops at this position. The reason it slowed down is because it did have the reattraction problem at each one of the rotor magnet groups. However, once we have the carriage shifting mechanism set up with the magnetic repulsions at the proper locations, this problem should be overcome. And the question is going to be, can we move the stator magnet at that correct time, the timing point, to obtain the desired movement? Can we move it at least halfway? If we can, we guarantee continuous rotation. If we can move it past halfway, we will guarantee some amount of repulsion effect, which will enhance the rotation. If we can move it very quickly, we'll have a repulsion acceleration effect. So that's what I'll be working on now in the days coming, and I'll continue reporting on this. I thank you for watching today, and I'll leave you with a little spin here to watch as we end this video. Again, thanks for watching, and may the magnetic force be with you.